right, welcome. Good afternoon, everyone, for another Lunch and Learn webinar with WhyMaker. We are so excited to have you join us for this electrifying session. My name is Alejandra, your host, and today we are diving into the world of engineering, coding, design thinking, and electricity with our incredible partner, Lectrify. Lectrify is on a mission to make learning fun, interactive, and accessible. Today, we are very happy to host their new product launch, the Very Useful Monster, a curriculum that will have your students use programming, robotics, and their imagination. We are honored to have Diego Fonsen today with us to share their passion of learning by doing and how their products inspire the next generation of inventors. Diego, thank you so much for being here with us today. We can't wait to hear from you. And
Great.
before we begin, quick note, we will have time for a Q&A session at the end. So please drop your questions on the chat as we go. And now let's spark some creativity. Diego, the floor is all yours.
Great. Thank you so much. Yeah, welcome. Here to talk about a very exciting new project that I have developed for teaching the microbit called the Very Useful Monster. And it is really something that I have been working on over many years and plays on a lot of the design philosophy of our entire company and what we do. And so I want to give a little bit of background about us and then jump right into this project so you can see whether it's a good fit for what you want to do with your students in teaching coding and making. So let's just get started here and talk a little bit about myself. So I started in the world of making as a parent who was brought into a school in 2011 to help make a maker space in that school. And I ended up staying on at that school for almost 8 to 9 years as the resident tinkerer. So I built the makerspace, got it started, got it set up, and then worked very closely with the school and the students developing curriculum and that used maker-based education in what the teachers were teaching. So I worked with history teachers, English teachers, science teachers, art teachers across the board. We were very maker-based as a school and as a focus. And while I was there, I got a little frustrated with what was available for electronics, coding, and engineering. Specifically, back then, the two options were you would do like a throwy LED or a brush bot, and then there was Arduino. And it felt like there was so much in between and so much more that you could do in learning how to build circuits, how to be successful. The other thing that I also found very challenging as an educator was that a lot of the projects in maker-based education, especially in engineering and coding, were they felt a bit like 90% of it was about perseverance. It was really hard to build these things. It was really hard to get things done, and the way that specifically like Arduino, like a student would put all this work into it, and as soon as they moved their project, one wire would come loose, and you'd spend your entire time tracing and fixing this wire or fixing what you did. And you didn't get to that part that was the exciting part, which was the coding, which was here I have this amazing tool for physical computing. How do I code with it? So I started Imagination Supply Co. And our primary product line is Lectrify. Well, our only product line is Lectrify right now. So it's a little confusing. We go by Lectrify, but the company name is Imagination Supply Co. because eventually we hope to sell a lot more other stuff. But our electronics engineering and coding projects go under the name Lectrify. Very important to what we do is this constructivist design philosophy of low threshold, no ceiling. And we try to design things that students can engage with right away, but give this ability to explore and try new things as they do it. And that is what we've been designing around ever since we got started. We have tools from K through 12. We, simple circuits, simple logic, and then coding. And our coding is primarily using the microbit. And that's what we're here to talk about today, which is a project around the microbit of how you can take the microbit in exciting ways using this concept that I've called the Very Useful Monster. The one thing I want to just say as a general philosophy that I notice is that when people have a makerspace or when people are trying to teach in these spaces, there often are three kind of, I call them centers of gravity, that are the goals of this space and the goals even of your coding. What are you trying to do? Are you just trying to teach that, or are you also trying to teach the art of making, or also you trying to teach design thinking? Or are you trying to balance all three of those? Are you trying to teach the craft, the actual specific concept, or are you also using it as a vehicle for teaching hands-on making, or as a vehicle for teaching design thinking? And often when I ask teachers or makerspaces, what do you want to do of these three, they say yes. They try to do all of them. I think it's important you have a focus of where your primary goal is, so that when you design your projects, you know where the students are going to spend the majority of their time. And this project, you can see, you can choose where to spend your time. Do you want to spend a lot of time using this as a vehicle for teaching design thinking? Well, here's one way. If you're trying to use this as a vehicle for teaching coding and not focus much on design thinking and making, there's a way to kind of think about it and do it that way. Or if you want to focus on making, you can focus on that side of it. And that's an important thing I look at when I design curriculum. Um, so like I said, project-based learning, design principles, low threshold, no ceiling. The other part I want to talk about is authenticity. And what I mean about authenticity in the case of coding sometimes is I would watch my students, or even my own kids would, early on, this was like in 2011, 2012, where they would often be given a project where they had to code a presentation using Scratch. And these kids already knew how to use Prezi. So for them, as a vehicle for learning coding, it was kind of annoying. It didn't feel authentic, because why would I ever code a presentation in Scratch when I can do it so well in Prezi? Why am I messing around with this not so helpful area when there's, so for authenticity, I mean, there has to be a logic to why am I doing it here, and why is it, that why am I actually learning this and applying it, and is that way of applying it a logical vehicle? So those are the many things that go on in my head as I think about what to make. And along those lines, I've come up with this very useful monster project. And the very useful monster project really is just a framework for approaching your coding and approaching your making of and learning how to code, that gives it an underlying theme and logic to what you're doing. And what you see here is kind of like the life cycle of your monster. And the idea is that as your coding improves, your monster grows and becomes a more sentient or useful monster that your students can use for what is useful for them. And I purposefully use the vague concept of useful because I want students to be able to do something with it and to apply their own definition of what useful is. And I also chose monster because robot often tended to trend more towards the boys and the girls, whereas monsters can be cute and can be amorphous and everybody can own a monster and can do something with it. So these aren't very useful pets. They're not very useful robots. They're very useful monsters. And that said, if you look at your students and they are pet enthusiasts, or you have a theme around like robotics or around something like that, you can easily just take this concept and apply it to what you're doing. So if we go back to the general structure of this, the idea is we start with the beginning point of all coding, which is kind of like the hello world. And that's this first thing off to the corner. And in the microbit, the hello world program is giving it a beating heart, which is quite logical for our monsters. We give our monsters a beating heart. That is we learn to code and we start to expand. From there, every new thing we explore, inputs and outputs, is this monster reacting to the world, and how the monster interacts with the world are inputs and outputs. We talk about functions as memories, as almost reflexes. Where there's a logical reason to explore the idea of a function, because once we give our monster once a monster comes alive, let's say we want to say, what does happy mean with our monster? Our monster, when it's happy, might have a smiley face. Its eyes might be a specific color. It might have certain other features. And then that block of code becomes happy. And now there's a logic to why we are using a function, because we're going to use this block of code over and over again. And then as we start to give it other emotions and other feelings, those become other functions that we can use. But then when we start applying logic and loops, the monster becomes more sentient. It becomes more, it reacts in very specific ways to the environment around it. And students can explore and define how their monster interacts with the world by its, but through their coding and logic and loops and all those, those things start to have a logical sequence. You have, and that kind of, just to sidebar here, one of the things I found very challenging sometimes with a product as powerful as the microbit was that it could do so many things. And that's why I wanted to have this thematic wrapper. And that often when you were teaching the different things the microbit could do, it would feel like very disjointed. I'm going to be talking about it can do inputs and outputs. It can play music. It can light up things. It can run motors. But putting that all together didn't make logical sense. And that's really what this monster was, a way of saying we're going to explore the breadth of physical computing and get it to the and do it through a logical vehicle, a logical framework that keeps building on itself. The other thing I want to talk about here is, I've been talking a lot about the concept at a high level. At the far end of what we can make with this is a design thinking project where your very useful monster, the more useful you make it, the more you can introduce a design thinking element to it. And in this case, the example that I give, and you can see this, the little monster here is thinking of a duck, because I often have the students watch a video that Aflac did a while back about a little stuffed duck that they would give students with going through chemotherapy. And it was a very nicely done example of how simple a solution can be. You have students who are going through chemotherapy, and I mean, not students, children going through chemotherapy, for which is a very boring, a very scary, a very long process. And by giving that, the designers designed this little stuffed duck that the children could interact with, and it would keep them happy as they were doing it. They would keep them, focused, and give them a vehicle with which they could communicate to the doctors, to their support staff. And using this very simple little duck, it relieved their stress. It relieved it made their experience generally better. And I think it's a nice accessible example of, there are many health things. Students may have a family member with diabetes. They may have somebody who needs to remember to take their medicine. They may have a grandparent with dementia, that they can start to think about, how would I make my monster helpful for them? Or how do I make my monster helpful for somebody who has X or Y problem? And that's the kind of design thinking project that we can do with this. So you've got this vehicle that starts with this life cycle of going from the very beginning learning, and then you learn every dimension of the microbit as it grows, using your code and using what you're building there. I'm gonna now kind of switch to my little split screen here and show some concrete examples of what you can do. But first, I want to just describe a little bit of the product. These are two examples of finished monsters, but I want to quickly describe the actual product that we're using, and touch upon some more of the general philosophy of what we have. So the very useful monster is based primarily on a bundle of parts that we have sourced and put together. We call the computer science activity bundle. This bundle has all the parts you need to go through the standard Microsoft Make Code Intro to CS course and curriculum, but it also has the parts that I have kind of curated and found over time that work particularly well with robotics and cardboard robotics. So one of the things you're going to see here is that I have this very useful monster kit can be done just using cardboard and this kit. So found materials, cardboard, your own parts, and this kit, you can build a very useful monster doing that. That said, if your focus is mostly on building, getting the kids to have a quick monster build project, but then focus on their code and refining their code, we do have these kits that let you build a modular monster like this one that has different teeth. This, you can swap them out. Of course, I don't have the other teeth within range right now. Oh, here's one. No, this one's actually the same teeth, but in a different color. You can swap out the eyebrows with different parts. Um, this is a modular monster kit, which is made out of 3D printed parts, which we provide you the links. You can print them yourself. We also can explain to you how you can make your own parts for it. But if like I said, if your goal is primarily just to get to the coding, have them have fun with the coding, the kit just lets you get there faster. It gives you the ability to build a very useful monster that can be a chatbot. It can be a robot you can control with a remote control. It can be many different functions, but still give a little bit of personalization for the students. But if you think of that triangle that I described of the different focuses, is it coding, is it making, or is it design thinking? With the kit, you can jump straight to the design, to the coding, and maybe to the design thinking. And the making is a quicker part. Whereas if you're going to do cardboard robotics, maybe you spend more time making because you're exploring how do you build structures out of cardboard? How do you build pieces? How do you assemble and make that what you want? Anyways, so the kit will include the computer science activity bundle, is a primary part. And then we have an add-on kit that provides you what you need to make this monster. The computer science activity bundle starts with a board we designed for the microbit that we call the Bit Explorer. The Bit Explorer is a fun-shaped board that has an edge connector, has 3 batteries on the back, easy access to all the pins along the back here, very well marked, easy access to plugging things in. So one of the things that's very important for us is that you can use any tools out there for making. And so all these pins use the standard, what they call DuPont connectors. You can plug those in. You can jump it into a breadboard. You can jump it into a servo. You can jump it into LEDs. It's very easy to build around these with these pins. So you are not stuck with any proprietary add-ons or components. You can just plug most things out there that work on it. It uses 3 batteries along the back, and the battery pack is built in. And this is important because now your servos and your motors have plenty of power for building what you want. If you buy these in 5 packs, they will often come in, and you can ask for it or not like this, but they come in 5 different colors so that the students can tell apart which one they want, which one is theirs that they're working with. These are the primary colors. The red is the one we usually, if you were to buy a single one, you'd probably end up with a red unless you asked for specific colors. We typically are like Henry Ford, red is the most common, but for bundles, I do like to have different colored versions of the board because it makes it easier to just have students differentiate which is theirs and which one are they working on. Then the board itself, like I said, very easy to program to with the microbit. It's designed to this is a vehicle that you can now do all your cardboard robotics and building around. And there's a lot I could go into on that, but don't have as much time, so let's jump into the rest of it. The rest of the kit comes with parts that are needed for making. They include a set of instruction cards that are used for as reference, and the general structure of the cards is the front has an image to explain, and the back will describe how to code to that area. So there's the I2C port. It shows you where it is. Here's the front. This is how you connect the I2C port. Here's how you connect a pin to it. Here's servo motors. This is how servo motors, this is where they connect. This is how you write sample code for them. So there's 5 different cards in here, and we like cards because as much as people can look things up online, it's so much easier to just look at a card as a reference. So that the box controls that has that. Inside, there's also just a list so that students know what to put back inside this reusable box, so that when they pack up, they can double check and make sure what's in there. It does include some glue dots. They are a very handy way of building, and I think I call them one of the much safer than hot glue guns. I do love my hot glue gun, but I think it's the most dangerous tool in most maker spaces because it is probably going to cause the most injuries out of any tool there. Everybody burns themselves on a hot glue gun, no matter how smart they think they are. Um, Also includes some wheels that you can use for cardboard robotics, also that are also used in the in this monster kit wheels. Inside is a bag of parts and components. The components include 2 orange servos. These servos are made by a company called Geek Servo. They are very similar in function to the standard little blue servos you've probably seen before. But what I like about these servos is they are super easy for building around. Because they have these 2 holes here, I can easily align it to a box of cardboard, poke 2 holes in it, and then either zip tie or use a pipe cleaner or use screws to fasten this onto that box. And now I use any box out there as a chassis for my robot. And that's visible even in this little monster that I built right here out of cardboard. I just poked 2 holes and I screwed this guy down with the screws that are included here. And then you can see the inside of that servo is actually just held in place with a pipe cleaner. But I'm able to build a very robust build and a very reproducible, robust cardboard build using found materials, using simple craft materials, and using motors like this that have these holes in them that make it easy to fasten really helps. So I include these in because I'm a big fan of them. The orange ones are also color coded. So these are the continuous ones. These are the ones you use for making wheels go forward and backwards. The gray one is a positional one, and it's used for as a traditional positional servo for any projects you have. Also included are some are different cables. We have some DuPont connect cables, so that if you heard me say these are standard DuPont pins and you're like, I don't know what that is. Well, this is what they are. They're just these pins. They are these connectors that have these. In this case, these are both what they call female. You would plug these in, but I can also plug in to the back of the board and put an LED onto here and easily trigger an LED that way, simply by plugging this in and plugging it into the back of the board. So it makes it very easy to build and build in a robust way, because I can wave this thing around and it does not fall off on me. It doesn't fall apart. And that's what I mean by my focus on a robust build is that I want it to be, easy and straightforward, but also not constantly fall apart, because you don't want students to always be, putting their project back together every time they move it or every time somebody touches it and some part falls off. That is a great teachable moment, and there's a lot to be learned from that, but it shouldn't be the primary learning point of most projects. It shouldn't, troubleshooting and fixing things is an important thing to teach, but it shouldn't be the primary teaching goal of everything, unless you want it to be, and then you can let them build stuff that falls apart all the time. The other part I really like about these servos is that because they are designed to work with Lego, for one thing, you can build with Lego. And that's something that was mentioned in the slide earlier, but I should highlight all my products from the beginning have been compatible with Lego. And by compatible with Lego, it means that they are spaced out and can snap onto Lego. So all the space between this hole and this hole across here is on an 8mm on center distance. So this is some multiple of 8mm. I don't remember off the top of my head. And all these holes down the side here also are compatible with Lego. They can snap onto Lego, and they're also active connectors, and that as they're marked on the back. So you can build with Lego if you have Lego kicking around using these boards. These servos also can build with Lego. They snap onto Lego. They work with Lego. But on top of that, this shaft here, which is a Lego shaft, is a little cross, which makes it super easy if you want to do 3D printing with your students to connect something to it. Because unlike a typical servo connection, which is a very fine little geared tooth piece here, this one is much easier to design something 3D printed around that can just snap onto it. And so I include these servo horns I've 3D printed, but I also include, the wheels, and students can build their own things that can attach to the servo very easily because it's just a simple design to build around. Also, if you're doing 3D printing, building around Lego is a nice, easy design space to work in because you are, like I said, building. Lego is 8 mm on center with a 5 mm hole. So you can design around that and build what you want using that. So then that's the core piece. Or there's also another one where if on one end, these are the DuPont connectors you can plug into the back of the board, and here you have alligator clips. So if you want an alligator clip onto something, you can easily connect alligator clips to your microbit board. So that's the kit that we work with. And like I said, the primary kit is this computer science activity bundle from which you can either do this entire curriculum yourself using cardboard robotics, or you can do it using the project that, the kit add-on that we provide. If you have your own laser cutter, if you have your own 3D printer, all of these parts are available for your own download and making if you want to. But if you don't have time for that, you can just buy them, and we're not selling them for a lot. I think they're only a $10 extra add-on to this kit. So it really is designed around how you want to teach, whether you want to teach by having them focus on their building, or if you want to teach by having them, just jump into the coding and take it from there. And this now then is a good time to kind of talk a little bit more. Oops, my screen zooms in on me when I do this. I wave my hands and my AI automatically zooms me in. To look at let's talk about what the actual curriculum looks like, and how are the different kind of modalities that we're teaching. So I've talked about how on one hand, the curriculum is designed, you can either do it with the kit or you can build it yourself with cardboard only and your parts. Let's talk about how you want to maybe explore teaching this and how we are supporting teaching this project. And then I'll show you specific projects, and then we can jump into some Q&A and discussion. So the first thing I want to talk about is that there is a website that has all of the curriculum on it. And this is developing, and we keep adding to it and expanding on it. But it's designed as a series of cards where as that life cycle that I described earlier is mapped out here. You start there. The start here is just kind of provides the overview. We start with the hello world, and then we start exploring. How do I do this? How do I expand and build? Then we go, once you do the simple intro to programming, what are the intro to basic, how do I control things? And each of these has there's curriculum with a description of how it works. Each of these cards you click on it, it'll explain through bring it to life, and then also has a video. If you're more of a video person, we do have a YouTube channel that has our videos, and there is a specific playlist all specifically around the very useful monster. So you can go to that oops, I'm starting it off here. I meant to click on the playlist. Let's try that again. I'm not so smart here. View full playlist. That's what I meant to do. There's a full playlist of videos you can watch and step through yourself. The idea is, it's important that this is your curriculum, that this is how you want to teach it, and try to make it as chunked and easy for you to say, okay, what do I have to do? What do I have to learn? And then how do I want to modify this for what I'm doing? And that's what these videos help you with. We step through every piece of it. and you get to build your own thing. One of the early ones that is a fun project for inputs and outputs, and also is a good example of how you can kind of think differently about how you might want to teach this, is this, oh, it's doing it again on me. Hold on. All right. Is this chatbot. So very simple input and output code. It is it's a we're using the fact that the microbit has a built-in sound sensor that we then map the sound sensor to the servo. So every time it hears sound, the servo moves. So when I turn this on, every time I open my mouth, it opens its mouth. So it hears sound and then it opens and closes. The same thing, this is what I was showing here, can be done in cardboard. So here I am, and every time I talk, it opens its mouth and it talks, and it moves. I like this as an example and as an exploration for teaching the inputs and outputs, because it can also be applied in many ways in how you want to teach with it. So one way you could do is, if you wanted to do a making project, is you could have this pre-programmed for the students as a taster of, hey, we're going to build this chatbot that is going to lip sync to music. And it's going to have one input and one output. And here are the parts. And you're going to build something that'll chat and do this with music. And students can then use that as a building exercise. But also, it's a good way if you want to do a quick intro of, because the code is so small, you can use that you can print out that one block of code and have the students then look at it, and you can do computer science without even the computer, where just by following the code they can understand how it works. And it's a good intro to what is possible, and getting them engaged into the project and into what they will be making as they go forward. It's, like I said, it's a very simple code, and I realize I didn't have it open here in a window, but I'm going to open it up right now just to show it. And give an idea. I'm assuming, and if you don't know make code, we talk through how to code to make code as well. There's lots of good tutorials, but I'm gonna now swap over here. This, you can see what it's basically doing is, it's just a simple loop that sets the servo angle to the sound level. And then below it, I've just put it's plotting so I can visually see the sound level. It's plotting it on the front of the microbit. But the code itself is just that one line. Set the servo angle to whatever the sound level is on the microbit. And that is it's a powerful illustration of what they can do with the code. But it's also kind of back to that logical and fun way of explaining it. It makes sense in the context of our monster to be using code like this, and then to be growing it. The next step of coding once they've explored some simple inputs and outputs, we start to expand upon the monster. And that really is taking a very deep dive in that Tamagotchi pet concept of using loops and logic to really keep expanding what your monster can do. And you can do that either once the monster is already in a format, or you can do it just using the board itself and decorating the board, and and sometimes you can give it a face, and now I can put a head on the monster, and I can do different things. I call this Mr. Potato Heading it, where I do think that there is a lot you can explore and do just by decorating, and maybe putting googly eyes on your monster. You can also just do that all with this monster. This monster is specifically designed for Mr. Potato Heading, because you can easily remove the pieces. And these pieces are all specifically designed to be easy for you to make. This ball joint is actually a standard piece on Tinkercad. So you can go on Tinkercad, show your students how to take that standard ball joint in Tinkercad and add it to something. I have one of the videos that you'll see on that website talk through how to make this ear. This ear is also a standard piece on Tinkercad. And so by taking that ball joint, connecting it with the ear, you can now give it a little ear. And or you can, maybe you want it to have claws, or maybe you want it to have a bushy eyebrow. You can design what you want. The other thing I'll say that is nice about this from a 3D printing project perspective is the pieces you are Mr. Potato Heading your monster with are small, so they will not take a long time to print. So that constant issue with a 3D printer of it being a bottleneck in your projects goes away when you have a smaller thing to print. And by designing something where the target is on the relatively small side, these will print quickly. And you can give those as the design constraints to the students, that you're going to build something that goes here and uses these constraints. And so that's a nice other feature of this. The this same mode, this, you'll notice that this here, when it's on its side, when it's upright, it can be, in chatbot mode. It's also designed to be put down flat, so you can use a remote control to then run this, and or use it as a motor that you run. You can 3D print a little seat for it, so that now it can bop around using a seat and do whatever, use this as a little buggy. This is designed to be modular and used in different ways, and for students to explore what they can make with it. And depending on what your goals are, let's say you decide they want to make their own monster now, or they want to make their own base and chassis. Well, they have a starting point. They can go in and design the rest of it however they want. It's super easy for them to connect theirs. These motors, like I said, just screw down or zip tie down, or you can use pipe cleaners to connect them. It's a very easy, non-proprietary building system that can work with what you have and design around it. There's curriculum in there that covers everything from the loops. We'll be adding more curriculums about series, and the curriculum continues to expand, but it'll continue to expand around making your monster more useful and giving it more capabilities. And you can see how the idea of giving, as your code, like if you're going to make it more of a Tamagotchi like pet, you can go from having it have very specific prompts, like, okay, make the monster wake up when it gets light. Oh, well, so then they think, oh, I'm going to use the light sensor that's built in and use that. Now I have to define wake up. I have to use the light sensor. I have to trigger it and it wakes up. Or you can say, make it get hungry and then it gets fed. Or you can talk about general concepts with the monster that are, the monster needs companionship, or gets lonely. What does that mean? How would you define it? We talk about interactions using the radio functions of the microbit. So the microbit can sense proximity. It can communicate with other microbits. And students can explore that in the context of their monster and how their monster can do these things. So that is the general kind of structure that we've got. And there's a lot more, but I'm just glanced at my clock, and I realized I'm running low on time. So I wanted to do this kind of quick wrap up and talk about this next steps here, and let you guys make your plug, and then we can take questions. You're on mute.
Oh, yes. Yeah, sorry about that. Thank you. Well, thank you, Diego, so much. That has been such an inspiring session. Thank you for showing us how the very useful monster turns very complex STEM concepts and turns them into hands-on activities for concepts that are so engaging. So now it's our audience turn for any questions, comments about the very useful monster. You can either type them on the chat right now or raise your hand to come off mute, and we'll tackle as many questions as we can. I do have one It's kind of two-in-one questions for you, Diego. Along the lines with classroom integration, one, what would you say with all the curriculum that you just presented, which is fantastic? What would be the ideal or typical age range for applying this curriculum to? And second part of that question, are the kits customizable in the sense of like, can teachers get as many as or as little as they need, depending on their classroom size? And you talked about the 3D printed add-ons. If you also have, I don't know, a list to choose from, kids sometimes want different and colorful options for decorating their
Sure.
monster.
Sure. So I would say it's as in the maker world in general, I would say, I always chuckle when I'm asked what's the target age range, because it really, in my mind, comes down to what are your teaching objectives with them. With I would, as a general rule, with the younger students, you are often just engaging them and having them interact with it, but you may not be trying to teach very specific concepts. And so in those cases, you may structure it so that they are interacting with it. They are they're being given much more basic projects and prompts, but they are still building and making on it. Whereas with the older students, you have an opportunity to really have them develop much more advanced uh, coding and give them prompts around more advanced coding. And that's why, even though the microbit was designed for high school, for middle school, it was, that its origin story was teaching middle school students in England, um, because you can program to it in Python, because you can program to it in JavaScript, you can provide very rich prompts for high school students and very um, engaging projects for them that isn't dumbing it down for them. It's actually quite engaging and quite uh, you know they can get a lot out of it as well. So it really comes down to what your goals are. And I'd say, it's middle school is the sweet spot, but you can easily go above and below based on how you design your prompts. But it is, I mean, let's be honest, the microbit was designed for middle school students. This is a lot of it is the middle school area, but high school students who are new to coding can get a ton out of projects like this, and even younger students. But in the younger students, maybe it's more of a build. Maybe it's more of a giving them stuff that they or giving them very simple programs to explore and scaffolding it a lot more for them. Your question about the customization and what is um, uh, a what's possible, the answer is yes. We are all of these kits are actually we are based in San Francisco. We design and make our kits here in California. We do source parts, so we're at the mercy of these tariffs, but we actually manufacture here. So we have incredible flexibility, not just in what 3D parts you can get in the kit, what this and that. We do have what we consider the starting point, and we provide those. And as we generate more STLs, we'll be posting those and sharing those out there. But if you can even customize, like if you had a school district whose school colors are blah blah blah, and you really wanted that, or if you wanted a shape, I mean, so you'll notice from one of the early ones, this is actually even this same board is the same design as one I did for Make, called the Makey bit. And so even the shape of the board can be changed depending on how many you need. So we have a lot of flexibility in customization is the short answer, and probably more so than you would expect, because we have a very nimble manufacturing. So it's not just the 3D printed parts, or not just the stuff that is made using traditional maker tools, but it's also even the PCBs, even the actual design of it. Since we design it, we own the designs, we do everything with it. We can easily do add-ons and extensions or modifications for people.
Amazing. We have another question from Kimberly. It says, can the microbit or code mode incorporate sensors or AI for pose recognition to use your body to control or move the monster?
Yes, and actually the right now it's not. So it is using your body. So right now, the way Microbit has released a AI module, and punchline. If you go to I've actually done a little video that you can watch that shows you how to do it. But it uses the accelerometer built into the Microbit, and it does learning based on the accelerometer. So by in the example I showed there, I show how you can either like dancing with your monster or rocking it to sleep as a way of like if you were you know doing like if you wanted your Tamagotchi pet to incorporate specific motions but very just very unique motions like the dancing and that now it's happy when it's dancing or rocking it to sleep, it only falls asleep when it's being rocked. You can train it using this the make code new version. It is, I think, technically still a beta product. And so, but it's fully available, it's free, it's out there, and it is based on training off motions. So you can use, and that's the other nice thing about by having the battery pack built in, you can move this thing around very easily. It's not a, it's a very easy thing to do. And let me just grab real quick an example of, it's so in this setup that I've even made this 3D printed ball that you can put the microbit, the whole thing inside of, and design projects around that and how you would interact with it, and when it's inside the ball. And you can imagine, you could at the most basic, you can play hot potato, but using that AI, you could come up with specific motions where you could, like students could say, okay, when this happens, do that, or train it for specific motions. So it is the AI feature is available. It's part of it's exactly how they implemented it using the make code, and it's quite an interesting implementation. I liked it. So.
Okay, a follow-up question. Can it work without you touching the microbit? For example, if I move my hand left, can it sense that and move the monster left?
So two things I would say. So I mean, the short answer is it no, but yes. And so the microbit itself does not have a sensor that can sense your motion. So this because it's nor does the Bit Explorer add that sensor. That said, there are two ways you could do something like that. Because there's an accelerometer, I could take one microbit and hold it, and its location could control the other one. So I could use this as a remote, and by turning it right, left, because it has the accelerometer, it can sense pitch and roll. It can sense the motion that it's going through, and then I can use the radio to send the second microbit. So you could wirelessly control another microbit with motion, but you'd need two microbits to do so. Is the answer.
Got it.
And
It is
but you can
possible
see now it is possible. Yes, it's just that that sensor is not built in, but it's almost even better because this is this controller, and that gets back to even the age thing. So that remote feature of this was how the microbit implemented with Scratch, where this becomes almost like a Wii controller for your sprite. So having this remote Bluetooth, because the microbit has Bluetooth and wireless, and it has radio. I think with Scratch it's using the Bluetooth, but using the Bluetooth, it can, you moving it can control your sprite. Whereas if you're in your code, in Make Code or in Python, you can have one microbit control another microbit. Another thing I'll just highlight about that I really like is the like in sample code that I have done for this. Like this here is a little remote control that I have made that just looks like a remote control, and so it lets you remote control model. But because the microbit has 100 channel, well, actually, it has 101 channels, 0 to 100. You can control one remote can control 101 different other microbits. And in this case, I just by changing the channel, I can just push a button, change the channel on the remote, and control a different microbit. So one microbit can control up to 101 other microbits. So that what I like about that is that if you want to do that remote control thing, you could maybe pre-program the remote one way and then have the students program their robot, and then they can test it out. But you don't need a one-to-one. You can just say, okay, when you're ready to test out, grab the remote and test it out against your monster, or your robot, or whatever it is. And it's very easy for them to work with that. So the microbit is incredibly powerful in what it can do, and that's why, even though it was designed for middle schoolers, it can do so much more. It's so much more powerful than that. And I do think that, as a high school, even at a college level, a lot of students could get something out of the microbit. So
That's amazing. Amazing. Thank you so much. And also thank you for all the questions. They're very they're very great. Now, as we can see on our screen, we have one quick announcement before we wrap up. WhyMaker is hosting a clean energy workshop near you. Did you know that the New York State climate agenda is creating thousands of clean energy career and job opportunities, and our students just need to be ready for that? WhyMaker's free hands-on workshop equips New York State certified educators, grades 4 to 12, with everything you need to bring clean energy content into your classrooms or your program. Here's a little quick view of what you will walk away with. You will walk away with CTLE credits, classroom-ready materials and full lesson plans, $250 to $300 stipend, hands-on training, a New York State Clean Energy Expert Digital Badge, and new educator connection/friends. So our upcoming dates are July 11th in Buffalo at Northland WTC and July 22nd in Hudson Valley at sunny New Paltz. Also, an extra little perk: if you refer a friend who registers and attends the workshop, you will be entered for a chance to win a $100 Amazon gift card on behalf of WhyMaker. Now, to register, you can simply aim your phone at the screen right now and scan the QR code, or go into the WhyMaker website. We hope to see you all there. And yeah, it was an amazing discussion. Diego, thank you so much. Oh, we have a question. Oh yeah, Kimberly says this has been a very informational session. Thank you, Diego. And thank everyone for being here. This is a wrap on another amazing discussion. A huge thank you again to Lectrify and Diego for sharing your expertise, and everyone for asking your amazing questions. So if you are ready to bring circuits, coding, creativity into your classroom, you can explore Lectrify's products now on whymaker.com website. And whether you're a teacher, a student, or a DIY enthusiast, Lectrify has something for everyone. And before you go, don't forget to follow Lectrify on social media at lectrify.it, and of course, WhyMaker at WhyMakers for more STEM inspiration. Also, subscribe to our weekly newsletter for updates and future webinars and hands-on learning tools. Thanks again, everyone, for joining us. Keep tinkering, exploring, and innovating. Have a wonderful rest of your day, and we hope to see you all next time.